Okay, math muscle back after a few weeks off. Let's get started on lesson 3 on triangle congruence proofs. We're going to feast on these proofs. Yeah. Just take the spoon out, start just shoveling, just feeding your mind. Yeah. Nope. Nobody likes that. Okay. Here is what a 2-column proof looks like. This first, or in lesson 3 here, we're going to just kind of like lay it out there and show you the template. As we get toward the end of the unit, there are just going to be a bunch of blanks, and you're going to have to take what you know and go with it. Okay, so what do we know? Well, let's look at example 1. We've got this triangle split into 2 triangles. We're given 3 items. ABC is isosceles. We're given that AC equals BC. And we're given that CD is the angle bisector of angle C. So let's make some markings here real quick. If ABC is isosceles, what do we know about this triangle over here? Well, we know... Wow, okay. We know this is congruent to this. What else do we know in an isosceles triangle? Put away your phone. You know who I'm talking to. Yeah, put it away. Okay, what else do I know? I know 2 sides are congruent, and I know 2 what? Angles are congruent. Which angles? Say it. 1 and 2? No. I'm just looking at the outside triangle right now. What angles? A and B, correct. These 2 angles are the same. Okay, I always do my markings first if they're not already marked. Okay, so I think that takes care of that. I also know AC equals BC. Well, we already marked that, right? There and there. So I go on to my third item here, which is CD is the angle bisector of angle C. Now, Adele, 1 and 2. Angles 1 and 2 are congruent. Okay, at this point, as you look at this, which of our 4 congruent statements would we say is true? Yeah, somebody said it. Angle, side angle, yeah. Well, angle, side angle has the side directly between the 2 angles. Right. So if I were to split this triangle up into 2 triangles, here's one, it's ADC. Here's the other, it's the BDC. These are my markings. I notice that I have an angle, then a side, then an angle congruence. Angle, side, angle congruence. So let's move on to our statement justification 2-column proof. The first statement you always want to put in there is what you know, what you're given. We're given that AC is congruent to BC. How do we know? Because it's given. Oh. Always put your givens first, okay? I gave you a little hint on the next one. Definition of angle bisector. Well, what do we know based on that? What 2 angles do we know are congruent due to an angle bisector? Angle 1 and 2. So our next statement would be angle 1 and angle 2 are congruent by the definition of the angle bisector. Okay, what's next? Because right here, all I've done is I've shown a side congruent, an angle congruent. We determined at the beginning, do we have another side or an angle? We have another angle. So our other angles that were congruent were angles A and B. Oh, uh-oh. Ooh, we did it a different way here. Okay, this is an alternate way to do this, and I'm going to go through this way just because. If I had gone this direction with the proof and said that those 2 sides were congruent based on, what's that? What property? Remember that property? Reflexive property, anybody? Is that coming back? How do I know that these 2 sides are the same? Because they're shared, right? They have to be the same. That's the reflexive property, and yes, you can state the reflexive property as well. Okay, there's the reflexive property. Okay, so based on this, okay, what do you suppose my proof will be based on? Angle side angle or side angle side? Side angle side. That's the justification for why these triangles are congruent. Okay, last thing I want to show you on this is what you want to show. What you want to show is always your last statement. My last statement. Triangle ACD is congruent to triangle BCD by side angle side. Okay, so we skipped example 2. Just weren't feeling it today. Don't do that in your daily life. Always grind it out, just gains. Example 3 here tells us that ACD is isosceles again, with AD congruent to CD, and BD is a median. Okay, so let's do some markings here first. I'm going to group these two because I don't want to make the same mistake I did in the last one and go too far with it. So using that, I'm going to mark AD congruent to a CD right there. Boom. Anybody see a reflexive property out there potentially? No? Yes? Yeah. How about BD is congruent to itself? Oh, look at statement number 2. Yeah, that's a good indication, right? Okay, so I've got both of those. What is a median? Median cuts what in half? The triangle. So a median from this point over to this side, that's a median, cuts this opposite side in half, right? It doesn't cut this angle in half necessarily. Doesn't necessarily cut that in half, but what it'll do is it'll make AB congruent to BC. Would we have enough at this point to say these two triangles are congruent? Yes, our favorite one, the one you can't screw up. Side, side, side. Cool? So let's go through the formal part of the proof. Justification. Given. Well, what was given? AD, say it again. AD equals CD. Now I'm going to say AD is congruent to CD. AD equals CD is just that their lengths are the same. We want congruent statements, not equations. So AD is congruent to CD. It's given. What would your justification be right here? Reflexive property. Good. Reflexive property. How do I know it's the reflexive property? Anytime you have anything congruent to itself, you got reflexive property as your justification. Okay, and then AB is congruent to CB. How did I know that this was congruent to this? The definition of a median, right? Everything you need, you guys, is given. You just have to decipher what means what. By definition of median. And what is always your last statement? What we're trying to show. This is always your last statement. Hey, that's a proof. Spencer. All right, I would like you and a neighbor to attempt this problem. Give you, I don't know, 3 minutes or so, maybe a little bit more, and then we'll come together and we'll see how you did. Okay, let's give this one a try together. How many of you said angle, side, angle? Okay, all right, cool. How many said angle, angle, side? Okay, angle, angle, side will work as well. Now this one is actually set up for angle, angle, side. And here's why, okay? First of all, given, we're going to do some markings here and show that that's parallel to that, which tells me that angle B and angle D are congruent. And it tells me that angle A and angle E are congruent. And we're also told that AB is congruent to DE. And right now, if you said to yourself, yeah, they're congruent by angle, side angle, you would be correct. Okay. The only reason in this two-column proof it's not correct is because it utilizes the vertical angles on the middle. So let's go through it for a second here and figure out why it is what it is. Okay, so given, we know that AB is congruent to DE. That was given to us. Alternate interior angles will tell us either B is congruent to D or A is congruent to E. So in this given proof, you could go either way with it, but it looks like I had gone BAC is congruent to DEC. So this is the blue angle A and the blue angle E written in 3 letters instead of 1. So just for the moment, I'm going to erase these green angles because I didn't use them, which I could have. I definitely could have, but I just used that. Okay, your proof wouldn't be wrong if you went angle side angle with this. Not at all. But if it's templated for you, use what's given to you. Okay, in the third statement, it says ACB is congruent to ECD. That means angle C is congruent to angle C, which some might say reflexive property, but in this case it's not. What would it be? Vertical angles are congruent. The definition of vertical angles. And of course, this would be congruent by what? Angle, angle, side, or you could call it side angle angle. Okay, I don't know which one I go with here, but looks like that's the one, side angle angle. Gains.